Hey everyone, Mr. Boykin here. We're on Unit 9, Lesson 6, and we're continuing to look at linear equations and different ways to graph them. So first of all, remember that we've got these three different forms of a linear equation. We got the general form, which is in the form ax plus by plus c. And we've got the slope y-intercept, which is y equals mx plus b. And we've got the slope point form, which is y minus y1 is equal to m times the x minus x1. So if we go to class example 1, we can see that there are three different graphs with three different forms of the equation. Okay, so if we look at the first one and we're asked to graph that, okay, so that's this one right here that we see in the slope y-intercept form. So what do we need to know about that? Well, I know that the b is the y-intercept. Okay, I know the y in this case has to have a value of positive 1. So the coefficient in front of y has to be positive 1, which it is right here. And that's if that's true, then the b will be the y-intercept and the m will be our slope. So going back to our equation and the graph, you can see that 4 right here is in the b position, which is the y-intercept. So this is the origin right here at 0, 0. So going from there up 4 units will get me to the y-intercept right there. And the slope, m, is equal to 2. And remember, we're looking at y over x, the change in y over the change in x. So this needs to be put into a fractional format like that. And we also want to realize that this is a positive slope. So another way to represent a positive slope is with a negative over a negative. So both of those work. So technically what I want to do is go from my known point, which is the y-intercept right here, and I want to go up 2 and right 1, up 2, right 1, up 2, and right 1. And those will all be points. And right here I've stated that it can also be negative 2 and negative 1. Negative in the y is down and negative in the x is to the left. So from this y-intercept right here, I should be able to go down 2, left 1, down 2, left 1. So with that, I can just go through and make a whole bunch of points. So up 2 over 1, up 2 over 1, up 2 over 1, etc. And from the y-intercept, I can go down 2, left 1, down 2, left 1, down 2, left 1. And I get these points that all line up, form a straight line, and if I take a line, I should be able to go through all of those if I've drawn it precisely, and I put 2 arrows there indicating that that line would continue on forever and ever in both directions. Okay, so I've labeled in this case like 7 or 8 points, but really there are infinite points along that line. Okay, so let's look at part B. I've got y minus 2 equals 2 times x plus 1, and that's going to be this format right here, the slope point. Okay, so what do I have in there that I can work with? Well, this one is my y, and that is my x point that I can put on the graph, and that m is going to be my slope. What you need to recognize right here is this says y minus the y coordinate and x minus the x coordinate. So when we go back to question B right here, it does say it is in that format, y minus 2. Okay, so basically that 2 is going to be my y point, coordinate of the point. So I have a point here, it's going to have an x and a y. My y is 2. Now, a lot of people will end up putting negative 2. It's not negative 2 because the format of the equation is y minus the y point. So with the x, it is also x minus the point. So it'll end up being a -1 for the x. And that's because this should be set up like x minus the -1. So -1 is the x point or x coordinate, and the minus negative together are going to change that into a plus. Okay, so I now know there's a point on here that's at -1 in the x, 2 in the y. So -1, 2, there is a point right there. Now if I have a point and a slope, which I have, it's the same slope, 2 over 1, or -2 over -1, I can now do the same thing I did in the last one, which is go from the known point that we have up to and over 1, or down to and back 1. Okay, so I just need to lay out those points again, up 2 over 1 for each one of those, and down to left 1. And you can see we get the exact same set of points going through there, forming a line. Okay, so what do we know about the equation A and equation B? Well, they are the same. They're in different formats, but they are the same line. So we're probably assuming that part C will give us the same line again, except that one is in this format right here, the general form. Okay, so from the general form, I can't really always pull out a slope or a y-intercept or anything like that. So in this case, it's best to create 2 points. So in here, I can sort of replace x, and then I will be able to solve for the y, because the a, b, and c are going to be known values. Okay, so, and if I replace the y, I can solve the x point coordinate of that point. So we can really choose any points, but quite commonly we would choose the x-intercept and the y-intercept. Okay, so if I look at this equation right here that says 2x minus y, so it's -1, the coefficient is a -1 in front of the y, plus 4. So to figure out the y-intercept, I'm going to replace the x with 0. So essentially this becomes 2 times 0 minus y plus 4 equals 0. Now 2 times 0 is basically nothing, so that gets eliminated. I'm left with -y plus 4 equals 0. Now to solve for y, I'm going to add y to both sides, canceling it on the left, and I end up with a y equals 4. So that is going to be my y-intercept at 4. Okay, now what about my x-intercept? Well, my x-intercept is when I replace the y with 0. So it's going to be 2 times x minus 0 plus 4 equals 0. So I can just eliminate that 0 from the equation. So we have 2x plus 4 equals 0. I'm going to minus 4 from both sides. That eliminates anything, that 4 on the left. And now I'm down to 2x equals -4. Then I'm going to divide both sides by 2. And I end up with x equals -2. So that's my x-intercept at -1, 2. Now, just to show you that that will work for any point, just resize this really quickly, move it out of the way. So let's go, we know it's the same line, so let's go grab any one of the points that are on one of these other graphs. So if I look here, this point, this point right here is going to have an x value of 4 and a y value of 10, 11, 12. So essentially, if I replace the x with 4, I should come up with 12 to prove that that's the case. So I could just choose any x value, and I can solve for the y value. Okay, so I'm going to get 2 times, in this case we'll just say 4, minus y plus 4 equals 0. 2 times 4 is 8, minus y plus 4 equals 0. Then on this side I've got an 8 and a 4, so I combine them together, it's going to be 12. So 12 minus y equals 0. And then I would just add y to both sides to move that y onto the positive, and I end up with y equals 12, verifying there is a point where it's 4 in the x and 12 in the y. And again, a line would just go through all these points and 2 arrows to indicate that it moves forever in all directions. Okay, so moving on to class example 2, we've got 4 equations and 4 different graphs. So remember to, we just want to be able to analyze these graphs to begin with. So I can see that there are 2 negative graphs and 2 positive graphs. So what we do is we approach the line on the graph from left to right, and if it goes down, that indicates that it is a negative graph. So A and C are both negative. And if I approach the graph from the left and hit the line on the graph and it goes up, then that is a positive graph, positive slope. Okay, so I can use that when I'm going to be determining equation 1, 2, 3, and 4, which one of graph A, B, and C, and A, B, C, and D do they match with. So the other thing we can get on these graphs is the slope. So if I go from any point on that I can see and I try to get to another point that crosses one of those lines, I can see this goes down 1, 2, 3, 4, and over 2. So it goes from this point down 1, 2, 3, 4, and over 2. So it has a slope of 4 over 2, which is 2 over 1. So this one right here has a slope equal to 2. Okay, and now because it's a negative slope, it's actually, negative 2. Now if I look at graph D, it seems to be around the same slope, just going in a positive direction. So I'm going to find 2 points on here. That's probably a point, which means I should be able to go down 2, left 2, or up 2 and right. Or sorry, let me do that again, can't count. Down 2, left 1, and up 2, right 1, which gives us a slope equal to a positive 2, which is the same as 2 over 1, and this would be a negative 2 over 1. Okay, what about the other slope, graph B and C? They seem to have the same slope, but one is positive and one is negative. So again, if I find 2 points on there, from that point right there, it looks like we're going to be going, it's hard to actually see where it crosses. Sometimes they don't cross perfectly, but it looks like it goes up 1 and over 1, 2. So it looks like a slope of 1 over 2. Okay, let me just write that down. So slope is 1 over 2. That one's positive, so this one would be a slope of negative 1 over 2. Okay, so let's analyze the first equation. So it says 2x minus y plus 3 equals 0. So in this case, I could replace the x with 0, leaving me with negative y plus 3 equals 0, and move the y over and I get y equals 3. But with this one right here, if I just move the y over right now, it's going to be y equals, and it's going to leave me with 2x plus 3. So in this case, it tells me that the slope is 2 over 1 and the y-intercept is 3. So it's a positive slope, which means it can only be graphs B or C, and it's got a slope of 2 which is going to be graph D, and it should also have a y-intercept at 3, which it does. So this is graph number, or equation number 1 right there. If we look at equation 2, it's already in that slope y-intercept form. So I've got a slope of -2, which is graph A, and it's got a point at a y-intercept at 3. So right there. So this would be graph number 2. And let's look at graph number 3. Well, right here, I can see that it's got a slope of -1/2. So that would be graph C. So that indicates to me right here that this is going to be equation number 3. Leaving graph B should be 4. Now again, in this case, it's not in a format that's going to really allow us to see the slope and y-intercept, so I'm just going to move the x and the -6 to the other side by going plus x and plus 6, leaving me right now with a 2y on one side and an x plus 6. But remember, I don't want the y to have a coefficient of 2, I want it to be a coefficient of 1. So I'll divide everything by 2. That's going to cancel that 2 and leave us with the format y equals 1/2x plus 6 divided by 2 is 3. So this tells me that I should have a y-intercept at 3, which we do, and I should have a slope of 1/2, which I have right there. So this is graph or equation number 4. Okay, last class example, number 3 here. What if we're given these equations and they're in one of the formats, and we want to actually use our technology, use our TI-84 or whatever graphing calculator you happen to have? Well, what we want to do is we want to put it into the format that our calculator accepts, which is this format right here, the slope y-intercept form. So y equals something. So when I look at this first equation, it's not quite in that format. It's y plus 8 equals -5x minus 2. Now, all I really have to do is change this into that format. So if I minus 8 from both sides, that's going to eliminate that, leaving me with y equals, which is what I need, -5 times x minus 2 minus 8. Now that's not in any one of the formats really, but I should be able to, as long as it says y equals, I should be able to punch that in the calculator just like I see it. So -5 bracket x minus 2 bracket minus 8, and I should be able to graph that. I'm just going to make sure I have a 10 by 10 window. I do. So I graph it, and there is our line right there. Okay, if I go back into here, I'm just going to work that equation a little bit more. So I get y equals, well, -5 times x is -5x, and -5 times -2 is a positive plus 10 and minus 8. So I now can take this to simplified form, y equals -5x plus 2. And now that is in the slope y-intercept form, and if I go here and I put in a -5x plus 2 and I graph it, you can see they are both the same line. I should be able to go in there and turn one on and off, but they're both generally on the same line. So I'll turn that first one off, graph it. You can see there's our blue line. I go back here, I'll turn that one back on, turn off the blue line, and I should have the red line in the exact same spot. Okay. And I would do the same thing with this second equation right here. This one's a little bit easier. It looks like I just need to move the negative y over to the other side so it becomes positive. So we should just end up with y equals 4x plus 9. And then I can put that into my calculator again. So if I come into here and I'll just punch in the 4x, what is it, plus 9, and if I graph it, oh, I need to probably turn that one on, graph it, and there are my two lines. They're intersecting at this point. They've got different y-intercepts and different x-intercepts and different slopes. Okay, so now it says determine the x and y-intercepts of that line. Okay, so I have y equals 4x plus 9. Well, the y-intercept's easy because it's just that value, the b value right there, if I put it into that format. But remember, I could just use the equation like it was originally given to us in the general form there, and to figure out the y-intercept, I replace x with 0, and to figure out the x-intercept, I replace y with 0. So again, if I do this really quickly, if I go 4 times 0 minus y plus 9 equals 0, that gets eliminated. I'm going to add y to both sides. That gets eliminated, and I have y equals 9, which is exactly what I had by just looking at it in the other format. And what about the x-intercept? Well, that's when we replace the y with 0. So I end up with 4x minus 0 plus 9 equals 0. I'm going to get 4x plus 9 equals 0. I'm going to move the 9 to the other side by going minus 9 on both sides. I get 4x equals negative 9, then divide everything by 4. So I should get x equals negative 9 over 4. That's going to be the slope, which is, if we put that in decimal form, it's going to be, goes in there 2.5, so negative 2.25, I believe. 2.25. Okay, so that's about where it looks like it's showing up there. Okay, so let's go back and close the red one. So we're looking at the right graph right here. Now, how can I figure it out on the calculator? Well, on your calculator, if I hit calc, and it's just saying what is the x value? Well, for the y-intercept, the x value is 0, and just hit calculate, and it tells me right here that when x is 0, y is 9. That is my y-intercept. Okay, now if I'm graphing it right here and I want to find out the x-intercept, I need to go into, on our own calculator, hit second calc, but on this one, hit calc, and then I want to choose the 0 function, and it's saying what is to the left. Okay, well, I saw that it was sitting around negative 2.25, so to the left of that would be something like a negative 4. On your calculator, you're going to have to move that dot left and right using the buttons, and to the right, I could choose anything like even 0, negative 1, anything to the right of the x-intercept, and if I hit calculate, I get negative 2.25, confirming the work that we did. Okay, so that is it for this lesson. We need to move on to the assignment on page 595 and check your answers right there on page 598. Okay, see you in class.